Most people assume that running a powerful vision language model requires a massive GPU or a paid subscription to a cloud service. However, Liquid AI recently released a demo of their newest LFM model running entirely within a web browser. Using WebGPU and the ONNX runtime, this model can process images and videos locally. This means your data never leaves your computer, and you don't even need an internet connection once the model is cached on your device. I honestly think that is super cool. So in this video, we're gonna take a look at this model, see how it performs, run a little test, and figure out if it's actually as powerful as advertised. It's gonna be a lot of fun, so let's dive into it. So LFM stands for Liquid Foundation Model, and instead of relying solely on the transformer architecture, Liquid AI uses a hybrid design. It combines convolutional blocks with something called grouped query attention. The 1.6 billion parameter model is specifically tuned for vision and language. It is trained on a massive 28 trillion token dataset, which helps it punch above its weight class. In the benchmarks, it often matches the performance of models twice its size, while also being significantly faster on edge devices like laptops and phones. Now you might wonder, how did they manage to shrink this level of intelligence into a package that fits under 1 GB of RAM? Unlike other tiny models that use pruned or compressed versions of giant cloud models, Liquid AI uses a philosophy called efficiency by design. The liquid in their name refers to their linear input varying architecture, or LIV. While traditional transformers have a memory that grows larger the more you talk to them, Liquid model uses a hybrid system of adaptive convolutional blocks. These blocks basically act like smart filters that processes only the most relevant local information, effectively compressing the data as it flows through the model. This allows LFM to maintain its massive 32,000 token context window without the usual exponential slowdown or memory spikes that you see in traditional transformers. And there are specific technical details that makes this model stand out from the rest. First of all, it has a native resolution. It handles images up to 512 by 512 pixels without distortion or upscaling. And for larger images, it uses a tiling strategy, which basically splits the image into patches while keeping a thumbnail for the global context. And secondly, it's very efficient. Because of its hybrid architecture, it offers a very low memory footprint, often running under 1 GB of RAM. But I think the most impressive is the WebGPU integration. The Hugging Face Space demo demonstrates how you can use it for real-time webcam captioning. So let's try it out for ourselves and see how well it performs. All right, let's see how this thing actually works. I guess we should choose which vision model we want to load. Let's try the most powerful one with FP16, and let's load that in. Now this model takes a considerable amount of time to download, and this is all being downloaded on your device, so next time you open the application, everything will be cached. All right, so now we have downloaded the FP16 quantization model, and let's click on start and see how it works. Oh, look at that. A man with a beard and a hoodie is looking at the camera. Okay, so it's able to detect what kind of objects are presented in the video, which is pretty cool. So we can do like object detection. Let's see if it can detect a phone. Yep, it detects that I'm holding an iPhone with a black case. That's pretty cool. Look at that. It's really doing it in real time. I am impressed. So what if I do this? Does it recognize a sign? Holding a peace sign in his hand. That is pretty cool. What if I do a thumbs up? Yes, I'm giving a thumbs up. The model does detect everything that I'm doing in real time. Let's see if it can detect my microphone. Oh, it even detects that there's a sign road on it. Wow, it can even read text off the case, which is pretty cool. The fact that we're getting these captions in real time really shows that this model is very powerful. Let me try to turn off internet connection and see if it still works. So now I have turned off Wi-Fi, and yeah, we're still getting the same inputs, which is pretty awesome. So there you have it, folks. That is the newest Liquid Foundation model in a nutshell. I think it's super impressive how far these AI models have evolved in terms of quantization and the ability to run them on edge devices like my laptop over here. I think just 2 years ago, we couldn't believe that this could actually be reality, but now it's becoming more and more common to run these models on a WebGPU. So what do you think about the Liquid Foundation model? Have you tried it? Will you use it? What are the best use cases to use such a model? Let us know your thoughts in the comment section down below. And folks, if you like these types of technical breakdowns, please let me know by smashing that like button underneath the video. And also don't forget to subscribe to our channel. This has been Andres from BetterStack, and I will see you in the next videos.